Hello everyone, welcome back to the delivery optimization series. This is part 3 of the series, and in part 3 I'm going to walk you through the UUP workflow. So UUP workflow basically means the workflow which is followed on the latest Windows 11 versions, for example the 23H2 and 24H2 and even on 22H2, but on 22H2 build that is greater than March 2022. Okay, because I think UUP was introduced since March 2022. Um, all right. So um, okay, one thing I could be wrong about the year. It could be 2023 or 2022. I'm not sure about that, but um, I remember the month. It was March. Whatever the year is, it's either it's 2022 or 2023. Post which the UUP model was introduced. So basically, in this model, whenever we deploy the cumulative update, basically the quality update for Windows 11, um, so it follows another model. It follows a different workflow. Even on the server side, you will see that the update when you download the update on the server side, on the SCCM server side into the source directory, the size of the update is around 10 gigabytes, and it includes a lot of other files as well, which can be used by devices from other architecture or probably um, other editions, whether it's Pro or Windows Education or whatever it is. So in this video, we are going to focus on the client side basically. Um, so I'm going to walk you through the workflow that as soon as an admin deploys a cumulative update for Windows 11, 22H2 or beyond that, what is the flow that the client follows, the workstation follows. All right. So we are going to start with the workflow. I have already prepared a workflow for you guys. Um, because I didn't want to waste time by drawing this real time, as it may have wasted a lot of your time as well. So I've already drawn this workflow myself for you. So starting from here, this is a machine, and it again, the partial workflow would be the same, that the machine will reach out to the management point to fetch the policies, the deployment policy. And the management point will provide the deployment policy to the machine, and the component that does this task is the policy agent, and the corresponding log file is policy agent.log, right? And once the policy agent downloads the policies, it informs schedule, which makes a note of the deadline time, that when to activate the deployment. And as soon as the deadline is reached, or whenever the schedule component triggers the activation of the deployment, that trigger, the activation trigger, is received by updates deployment agent. And updates deployment agent triggers a scan in order to validate whether the update that is deployed by the admin is still applicable to the device. And the complete scan process happens. This time I have not drawn the complete scan process again, because I've already covered it in the last video, in which I explained the conventional update flow. Um, if you haven't watched the conventional update flow, I would suggest you to watch it. Um, Alright, so once the scan process completes, and you know that the scan is the core component which performs the scan against the WSCS server, or we can say the software update point is the Windows update agent, right? So this is the component that directly performs the scan against the WSUS server, and it identifies what all updates is applicable to it. And In the conventional workflow, we observe that. Let me open the conventional flow as well. So in the conventional flow, we observed that as soon as the scan completed, the Windows Update agent handed over the result back to WUI handler, and the WU handler handed over the result to scan agent, and then scan agent handed over the result to updates deployment, right? And then it reached out to updates handler to initiate the download of the update. But in the UUP workflow, here is where the track changes, the flow changes. Okay, so instead of Windows Update Agent, I mean, instead of updates deployment agent handling the download this time, because in the conventional workflow we observe that updates deployment agent uh, asked or it reached out to the updates handler to in order to initiate the download. So again. Um, Somehow updates deployment agent was the component that was controlling the download process here, right? But here it's not updates deployment agent who controls the download. The Windows Update agent, as soon as it performs the scan and it completes the scan, it does hand over the result back to updates deployment agent. So in the updates deployment log, you'll be able to see that the update is actionable indeed. All right, but this time the download will be initiated by Windows Update Agent itself and not Updates Deployment Agent. So Updates Deployment Agent is not going to initiate the download this time, or this component is not going to reach out to some other component to initiate the download like it happened in the conventional flow. Okay, so as soon as the Windows Update Agent hands over the scanned result back to Updates Deployment Agent, the download as well is initiated by Windows Update Agent itself. Okay, and how it does it? It basically creates DO jobs. And what are DO jobs? It's the job that the Windows Update Agent creates for the delivery optimization client. Delivery optimization client can also be considered a core Windows component. Okay. So Windows Update Agent creates DO jobs. It basically asks DO client that this is the update and can you initiate the download of the files. All right. Um, and Windows Update Agent creates multiple DO jobs. It can create multiple DO jobs for the same update depending upon the number of files that are present in that update. So I don't have the access to my lab. uh, I have created a demo lab for you guys because in the previous videos I wasn't able to show you things in lab, so this time I've created a demo lab for you so that I can show it to you. Probably in the next video I'll be able to show you how the update files look like. I mean how the UUP file structure looks like on the server side. So when you download a cumulative update on the server side, the file structure contains a couple of files. Some of one of them is .vim file, one of them is .psf file, and then we have a couple of cab files. Okay, so Windows Update Agent can create multiple DO jobs for each of those files. I mean, it can maybe in one DO job it can include two files, and then it can create different DO jobs for different files. It all depends on Windows Update Agent, okay, how it does it, how it decides to create DO jobs, and how many files it includes in a single DO job. It all depends upon Windows Update Agent. And once the DO job is created, so then the DO client is going to reach out to our DO cloud service. Okay, DO cloud service basically it's going to obviously reach out to the internet. So there are DO endpoint URLs that needs to be accessible from the client. And those endpoints are, let me get that endpoint for you. So these are the endpoints that the client machine should be able to access to. This is a wildcard because here this you this endpoint keeps on changing. Okay, I mean this part just before prod, this part keeps on changing. So that's why there's a wildcard here. So all these URLs that you see here must be whitelisted in your firewall so that the clients can reach out to these URLs when needed. All right, so the DO client reaches out to the cloud service, and then the DO cloud service has its own logic to find out the peers. Basically, um, depending upon the download mode what we have set. We are going to talk about download mode maybe in the next video. Okay. So DO Cloud Service has its own logic based on which it tries to discover the peers. Basically, it tries to find out what all peers has the content in their DO cache, which this machine is looking for. So let's say this is my client machine that needs the update, and I have two more machines in my subnet that already has the update content. Maybe they would have installed that update earlier. Okay, they have already downloaded and installed that update, and probably they might have cached the content for that update in their DO cache. Okay, so DO Cloud Service has its own logic based on which it tries to discover the peers from which of which it can provide the list to this machine, and then this machine can probably reach out to those peers to download some of the content um, for the update. Okay, so how it works is, first of all, what it does is when the DO client reaches out to the DO Cloud Service, first of all, DO Cloud Service decides in how many pieces a particular file must be downloaded. Okay, so let's say there were total 6 files or maybe 5 files. Let's say there are total 5 files associated with the update that we have deployed on this machine, and DO Cloud Service is going to divide each of those 5 files into pieces. So let's say it divided the first file into 6 pieces, let's say. Okay, and then it's going to tell the DO client that you need to download the content for this file in 6 pieces. Okay, and it also tells it that how many pieces it can download from peers and from which peer, and how much pieces or how many of those pieces can it download from probably a distribution point. Because if we are using SCCM and if you have created a package for that update and you have distributed to your distribution points, um, so some of the content or some of the pieces of that file the client can download from the distribution point as well. But who tells the client who is the who is the character here, let's say, who tells the client that you can download these many pieces from your peers and these many pieces from your distribution point? It's the DO Cloud Service that tells it. Okay, so DO Cloud Service first of all tells it that in how many pieces you have to download it, and then it also provides a list of peers to the DO client that you can download some of the content from your peers as well. Okay, and if none of the peers have the content that this client is looking for, then of course it's going to tell the DO client that you need to download all the content from probably your distribution point. Okay, so of course it's going to download the content in pieces only, because it's not going to download the complete content altogether in one go. It's going to a DO Cloud Service is going to divide the content into pieces irrespective of uh, whether that content is available on the peers or not. Okay, so let's say that um, DO Cloud Service divided the first file into, let's say, 20 pieces. Okay, or it can divide it into 50 pieces, let's say. So it divided the first file into 50 pieces, um, and it tells the DO client that out of 50 pieces, you can download 11 pieces from your distribution point, and you can download the rest of the 39 pieces from your peers. Okay, so the DO Cloud service can tell the DO client that divide this file into 50 pieces and sorry, download the download 11 pieces from your distribution point, and um, the rest 39 pieces you can download from your peers. So it's the same file, okay? It's the same. The file is the same, but it has just been divided into pieces so that the download can happen faster, and the client can get the content faster. Okay, and since the major part of that file, it's going to get it from peers, so um, we are going to save network bandwidth as well here. Okay, because only 11 pieces are going to be downloaded from the distribution point. So uh, that's why I have created three dotted lines here. So what these three dotted lines indicate that the DO client for 11 pieces, it's going to reach out to one another component on my client machine, that is Delta Download. So Delta Download is one other component on my client machine itself who listens the DO requests. Okay, so the DO client sends the request to Delta Download for 11 pieces, and the rest 39 pieces it starts downloading from its peers. Okay, uh, if I talk about the port that is being used here, when the DO client tries to reach out to the Delta Download, it tries to reach out over port 8005. And since the DO client and Delta Download both exist on the same workstation, it's not the scenario where the machine has to reach out to maybe some other server or other network server or any other workstation. All this activity is happening on the same machine, except the DO Cloud service because it exists on internet. So the DO client, that's why I mentioned the local host IP here, 127.0.0.1. So the DO client service reaches out to the Delta Download over port 8005 on the local host for downloading those 11 pieces. Okay, and what Delta Download does is it listens all the requests basically. Um, as I said, it's going to receive request for 11 pieces, right? So it's going to receive 11 requests from the DO client. And how those requests look like? Let me go back to Paint and probably draw something for you. So let's say that this is one file, okay? And the total size of this file is 500 bytes. Or yeah, let's say 500 bytes. It's the total size of this content. Okay, and a DO Cloud service divided this file into, let's say, multiple pieces. So it divided the file into 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. Okay, and it assigns byte ranges to it. Basically, the total size of this file is 500 bytes. So obviously, the first piece here, what would be the range of this first piece? So of course, the range of the first piece would be from 0th byte to maybe let's say 12. byte, right? So the range of the first piece would be 0 to 12. For the second piece, it could be 13th byte to 21st byte, or it could be greater than that. Let's say it's 13th byte to 25th byte, or let me change it to rather 150th byte. The third piece would be 151st byte to 200th byte, and so on. And similarly, the last piece would be could be something like 451st byte to 500th byte. So these are byte ranges. Okay, since we have divided a file whose total size was 500 bytes, we have divided into pieces, and obviously each piece is going to have a byte range. Okay, so that uh, when the machine is going to receive all those pieces, it can assemble them all together again based upon these byte ranges. So of course, from this ranges we can identify clearly that okay, 151st, this piece, the third piece, would be in the third, I mean it would be in the third position when reassembling the file, right? uh, we can identify from the byte range. So every piece has a byte range here, and that is why if we go back to the flow, just a moment. All right, sorry. So that is why if we go back to the flow, the delta download receives a request for 11 pieces. That means in total there would be 11 ranged requests. Okay, 11 range requests. Basically, all those 11 pieces would have a byte range, right? So that is why we can say here that the delta download is getting 11 ranged requests, and it totally depends upon delta download whether it want to cater all those 11 ranged requests together, or it want to batch the requests in separate batches. So let's say it received the request for 4 pieces, that is 4 range requests, and then it decided to batch those 4 requests in one go. Okay, so batching requests means that those 4 pieces are going to be downloaded together, and the rest 7 pieces it can batch separately. So the rest 7 pieces, the rest 7 range requests can be batched separately. So 4 pieces are going to be downloaded in one go, and in the second go, 7 pieces are going to be downloaded. Just a moment. Okay. So yes, so Delta download is it's completely dependent upon Delta download whether it want to batch all those 11 requests together, or it want to batch them separately. Okay, so it's not fixed like Delta download is going to batch, always batch 5 files together or 6 files together. So this number is not fixed. It depends upon, um, I don't know what the logic is, but it can batch, separate, It can batch the range requests separately, or it can batch them all together. It all depends. So let's say it created two batches for the 11 pieces. In first batch, it's going to download 4 pieces, and the second batch, it's going to download 7 pieces. 4 pieces and 7 pieces separately. So what it's going to do is it's going to reach out to CM Bits Manager. This is another component on my client machine, and the CM Bits Manager is going to receive um, two requests. Okay, one for each batch here. In the first batch, we have 4 pieces that needs to be downloaded, and in the second batch there are 7 pieces that needs to be downloaded. And for each batch, it's going to create a job for content transfer manager. So content transfer manager is the next component that comes into the picture, and for each batch, uh, one CTM job is going to be created. So since there are two batches here, so for the first batch, first CTM job got created, and for the second batch, second CTM job got created. And then the CTM content transfer manager is going to request for the DP locations via location services. So I have not drawn that thing here, but since I've already explained it in the conventional flow, so I'm going to assume that you already know that what's going to happen next. So content transfer manager is going to request locations, the content locations. Basically, it's going to discover all the distribution points that has the content, and not only the distribution point, uh, it can reach out to internet as well if required, or it can reach out to any other HTTP source as well. Okay, uh, we will talk about we will talk in detail how that happens, but for now let's assume that it's going to go to the distribution point only. Okay, so obviously it's first of all it needs to know that what all other distribution points who have the content. So it's going to send the location request to the management point via location services, and then management point is going to return the name of the DPs that probably has this content, and then it's going to create a job for DTS. So first CTM job will create a DTS job, and the second CTM job will create its corresponding second DTS job. So each CTM job has its own DTS job, and then the data transfer service is going to reach out to my distribution point, and it's going to download those pieces via bits. Okay, we have already talked about bits in the last video. So I have drawn two lines here. So these two lines are indicating that the two DTS jobs were created, and in the first go it downloaded 4 pieces, and in the second go it downloaded 7 pieces. And after downloading everything, it stores the content in CCM cache, um, and then so this is how DTS completed its download. So DTS got request for 11 pieces. It downloaded those 11 pieces, and it stored all those 11 pieces in the CCM cache folder. And what about the rest of the 39 pieces? So if I go back to the DO client, its corresponding log file is dosvc.log. So what about those 39 pieces? So DO client gets those 39 pieces from its peers via port 7680, and it stores all the content here in the DO cache. Okay, and the location of the DO cache is here. See Windows. Under Windows, it's service profiles, and then network service, and then app data, and then local, then Microsoft, and then Windows, and then DO, and then cache. Okay, so this is the location of the DO cache on a Windows machine. So whenever something is downloaded via delivery optimization, um, it's going to be cached here in this location. Okay, and if you go to this location, you will find separate folders getting created, and all those folders have a GUID basically, and even if you enter that folder, you may not be able to identify what content it is because the name of the content is changed in there. So you may not be able to directly identify what content has been cached, but there are still ways we can identify. I will show you in my lab, and probably in the next video. So the 39 pieces got downloaded by the DO client and it got stored in DO cache, and the rest 11 pieces got downloaded by DTS and it got stored in CCM cache, and then all those content is then reassembled, and then all those content is um, moved to the software distribution download folder. So from the DO cache as well, everything is moved to software distribution download folder, and then from the CCM cache as well, everything is moved to software distribution download folder. All right, and this is how the download completes, and then the installation begins. So you can see that in this workflow that I've created, a delivery optimization is an integral part of this workflow. All right, and we cannot eliminate this, at least on Windows 11 machines, because there is no way of eliminating it. Yes, there are workarounds, but if you really don't want to leverage delivery optimization, we won't be able to disable it completely. But yeah, there are still ways we can figure it out. Okay, I'll show you in lab. All right. So yeah, this is the workflow for the UUP workflow that I was talking about. That is followed on Windows 11 latest versions. Okay, and on server operating systems, so far delivery optimization is not followed. You can still leverage it if you want. It's optional for Windows servers, but as far as I know, since Windows Server 2025 has already been released by Microsoft, and it's already in use by many of the organizations. So as far as I know, Server 2025 also follows this UUP model. So it does not follow the conventional model. So I have not tested it myself yet in my lab, but yes, theoretically it follows the UUP model. So this workflow that I've drawn here, it's going to be applicable for Windows Server 2025 machines as well. Okay, so you can probably take a screenshot of this workflow, and it's going to help you while troubleshooting. Okay, I have written the name of all the log files that are that are part of this workflow. Uh, so CMBits manager, the log file for CMBits manager is cmbitsmanager.log. Every log file is based on the component name itself. So whether or not I have written .log at the end, you can assume that this is going to be the name for that log file. Okay. Let me see if I'm missing anything. I think this is it. Um, this is the workflow, and in the next video, we are probably going to dive into one of the machines that I have configured, on which I'm going to deploy a patch, and I'm going to show you real time to track uh, how to track the files that are downloaded via delivery optimization, and we are going to track each and every piece. Okay, each and every piece, whether it's going to be downloaded from its peer or whether it's going to be downloaded via delta download, and basically via your distribution point. So how many pieces are going to be downloaded via distribution point, and how many of them are going to be downloaded via peers, we are going to track all those things in the next video. So if you're liking the series, then I would really appreciate if you can like the video, and of course subscribe to my channel. This is the first time I'm asking you guys to subscribe to my channel. um, if you if you are liking my work, then please subscribe, and if you have any questions, please feel free to comment, and probably I can take up that question in my next video and clarify things for you. Thank you guys, thank you for watching.